Welcome back to A Quick Note. Today, we're diving into the fascinating world of water and ice, and trust me, it's cooler than you might think. Ever wondered why ice floats or why a gallon of ice weighs less than a gallon of water? Stick around as we unpack these watery wonders. Ever thought about why ice floats in water? Or wondered when water is the heaviest? And which one is usually heavier, liquids or solids? Imagine this: you've been playing outside all day, and now you're chilling at the kitchen table with a big glass of ice-cold water. Picture the scene: the ice cubes make a cool sound as they drop into the glass. When you pour water over them, they make this awesome hiss and crackle, bobbing up to the surface like tiny icebergs. So, why does that happen? What's the deal with ice and water? Let's dive into the cool science behind it. Ever pondered the peculiar mix that is ice water? It's like magic: solid water doing a little floaty dance in its liquid counterpart. How awesome is that? But let's get to the heart of the matter. Why does ice do the floating thing in water? So, the brainy folks in lab coats will tell you it's all about density. Density is basically how much stuff is crammed into a certain space. Ice pulls off its floating trick because it's less packed with stuff than water. Now, think of something way denser than water, like a rock. If you drop that rock in, it's going straight to the bottom. For things to float, they need to push aside enough liquid to match their own weight. It's like a balancing act of weights in the watery world. Cool, right? It might sound a bit odd, but the way ice floats in water is kind of special. See, usually, when things turn into solids, they get denser. But water does its own thing. It hits its highest density at 40 F, 4.4 C. And that's when it's like, I'm going to float my way into your attention. Now, here's the cool part. When water chills out and becomes ice, it becomes less dense. Why? Well, it's all about these cool connections called hydrogen bonds. Picture each water molecule as a trio. One oxygen buddy hanging out with two hydrogen pals. They're all bonded together in a cozy way, and this buddy bond makes water do its unique dance. So, in the end, water gets a bit rebellious. While most things get heavier as solids, water's like, nah, I'll be lighter as ice, thank you very much. And that's the magic of those H2O molecules doing their thing. Picture water molecules as friendly buddies holding hands with these bonds called hydrogen bonds. They're not the strongest links, but they're there, connecting the positively charged hydrogen and the negatively charged oxygen in nearby water pals. Now, as things cool down, these hydrogen bonds start acting up. They begin keeping the negatively charged oxygen atoms at a distance, creating a solid structure that looks like a crystal honeycomb, and we call this chilly structure ice. Here's the cool twist. The water molecules in ice take up about 9% more room compared to when they're in liquid form. So, in a way, ice is like the spacious, laid-back version of water, making it about 9% less packed or dense. It's like water's way of saying, I'll spread out and take it easy when I turn into ice. Nature's little science quirks at play. Imagine having a gallon of ice and a gallon of water. Here's the twist. The ice gallon weighs less than the water gallon. Now, when you drop that ice into the water, something interesting happens. The water, being denser, gives the ice a little nudge, making it float right up to the top. Now, why does this matter? Well, it's a super cool benefit for fish that call frozen lakes and ponds home. When the water turns into ice, it starts freezing from the top down, thanks to our floating ice friend. This is a lifesaver for fish because even if the surface is all frozen and chilly, they can still hang out comfortably underwater and stay toasty. It's like their own underwater winter retreat, thanks to this awesome water trick. That's a wrap on our exploration of the peculiar behavior of water and ice. Who knew H2O could be so full of surprises? If you enjoyed today's quick dive into science, don't forget to give us a thumbs up, and be sure to subscribe to A Quick Note for more bite-sized wonders of the natural world. Thanks for joining us, stay curious, stay subscribed, and until next time, this is A Quick Note, signing off.